Alaikum. I'm Asad Yusuf, Senior Medical Physicist in Section of Radiation Oncology, Department of Oncology, Aga Khan University Hospital. Also, I'm alumni of NED Engineering University of Karachi. I completed my MS in 2018. My topic of presentation is Audit of Treatment Planning System for Small Field Output Factor. As I work in radiation oncology, radiation deals with the cancer treatment. So in radiation oncology, we use linear accelerator, and the small fields are quite often used in IMRT, VMAT, and stereotactic techniques. Contents of my presentation include the purpose of study, introduction, methodology, dosimeters which we use to measure the output factor, comparison of measured data with RPC, and conclusion. The aim of this study was to audit the treatment planning system BEAM algorithm for small field output factor against the standard dataset produced by Radiological Physics Center from a multi-center study. Such data is critical for the validity of spatial techniques. Radiological Physics Center mission. Brief intro of RPC. Conduct on-site dosimetry. RPC measure the small field size output factor for X-ray energies ranging from 6 to 18 MV. Include all the brands available in the market. Datasets were measured at 10 cm depth and ranged from 10 by 10 cm square to 2 by 2 cm square. These data offer the radiotherapy community an independent dataset that can be used as a secondary QA dataset. Dosimetry. The first scenario was shown as a broad field scenario, like a traditional field. On the top, there is a flattening filter, and then we have a secondary collimator. And then there is a field of view extended direct beam from the source. Next to it is a profile shown with the dosimeter placed. On the other hand, small field scenario, where you can see the field partial view of extended direct beam of the source, and the profile shows the very narrow dose profile, and the detector size is greater as compared to the profile. So the small field range is less than 4 by 4 centimeter square. Anything less than 4 by 4 centimeter square considered to be a small field scenario. Methodology. Clinic's 2100 C series LINAC of 6 MV and 18 MV photon beam with the Millennium MLC 120 were used. Beam dataset were measured at 10 cm depth for 6 by 6 cm square to 2 by 2 cm square field size defined by MLC with a fixed collimator jaw of 10 by 10 cm square with 100 cm SSD setup. The measurements were with OSL, graphchromatic film, and pinpoint chamber. These are the dosimeters which we have used. Dose was calculated on Eclipse planning station with algorithm AAA algorithm and PBC algorithm. The measured and calculated data compare with RPC dataset. Selection of dosimeter is a challenge because we are dealing with a small field, so we need to consider the size of the dosimeter which could measure the small profile as you have seen in the previous slides. So we choose nanodots, which are quite small in size, about 5 mm in diameter and 0.2 mm in thick, as you can see in the figure 1. Graphchromatic flick, very high resolution. In figure 2 you can see, and the pinpoint ionizing chamber, especially designed for small field dosimetry. Its active volume is around 0.015 centimeter. Literature states that diamond detector or uh, diamond detector is much better for the small field dosimetry, but unfortunately we don't have that dosimeter in the department yet. The results of different dosimeters against the RPC. The chart 1 shows the RPC with the black line, and the others are within tolerance. Chart 2 is a comparison with the TPS, and you can see the AAA is much closer to the black line. Whereas in chart 3, 18 MV photon beam, the maximum deviation was seen with OSL, and we couldn't conclude that why it has happened with these results, and we need further study for this. Whereas with the TPS comparison, again the AAA is much better in the small field region. Result analysis. On average, the deviation of planning system calculated value for the multiple dosimeters are maximum, of course I am sharing, 4% for EBT3, 2% for both nanodots and pinpoint in 6 MV. However, EBT3 results seem to be better for 18 MV with a maximum deviation of 3%, whereas OSL and pinpoint show higher deviation up to 5%. We evaluate eclipse planning algorithm for PBC and AAA, in which we found that output factor for 3 by 3 cm square and 2 by 2 cm square field resulted in appreciable difference in calculated versus RPC dataset, but negligible one for the calculated AAA for both 6 and 18 MV. And conclusion. Small photon fields are frequently used in modern radiotherapy. Advanced techniques dictate the importance of small field dosimetry and commissioning of the treatment planning system. For small field dose calculation, TPS act like a black box equipped with a sophisticated algorithm for dosimetric calculation. Because it is commissioned with smallest of 3 by 3 centimeter square field size, whereas the calculation may include field aperture smaller than 3 by 3, even less than 1 by 1 defined by MLC in some cases. An independent set of output factor data produced by Radiological Physics Center has uncertainty of less than 2% provide excellent source for audit of our own center. These are some references for my presentation. The first one is, of course, the data which I have compared with. I'd like to acknowledge my supervisor and mentor, Sir Abdul Qadir, ICAPE Management, of considering my presentation for oral, and the NED Engineering University for giving us this such great opportunity and organized this conference and include the content of medical physics as well. Thank you very much. For your attention and interest. I'll be happy to answer your queries.